So the key thing with, like I said yesterday, the key things with these questions on what's this on the identities, it's all about what? It's all about practicing. Huh? So let's look at this one. So one thing about these questions is that when you look at a question, most people what they'll do is that they just get stuck and they don't do anything. So what I would encourage you to be doing is that once you see a question like this, just try to substitute something, because sometimes you may not know, and you just find that you just factor in something and then your mind just opens up, right? So try to look at any identities that you can figure out, try to substitute. And if it gets more complex, there is no harm in you just backtracking and say, okay, that didn't work, let me try something else. But usually people just see something and they give up there and then. So don't be that one, huh? So now, so we looked at identities yesterday, and you may want to remember that we looked at an identity which was, I'm writing it on my far right so that people can understand where what we are getting these things is coming from. Okay, so that's the identity there. So you see that identity there is matching there. So if you don't know that identity, then there's nothing much you can do. So again, my emphasis is practice as much as you can. The more you practice, the quicker you become at being able to pick out these things from the question and being able to work out these things. So there is no amount of questions that we can do together that can replace the advice of you having to try these things on your own, try these things on your own, because that's the only way in which you can become really quick in these things. So you see there, it's what? It's going to be cosec. Then, so if you want, you can put that. Then for this other sign, you see that there is something that we are looking at yesterday. We said, okay, and then you will realize that if I say, uh, how can I relate this to that? Okay, so you are thinking, okay, let me make, okay, so meaning one has to come to the left and, okay, and cosine, cos squared theta has to go to the other side. So you say, okay, this is what I will do. Negative there, right? So you see, so negative cos squared theta is actually equal to that. So you put it here. So having done that, you then say this is the same as, you know, you always go to the third letter, right? Cosec s is the what? Is the third letter. So That's same as 1 over sine squared there. Then what's then cos squared is? It's just that, which is the same as over 1. So when you write this, it's which is going to be, again, we did this identity yesterday. We said sine theta over that is tan theta, but cos theta over sine theta is cot theta. So again, that's an identity there. So you see, there you have it. So you've proven the identity. So you see, again, it's all about start from somewhere. Okay? Start from somewhere. Okay, let's look at something else before we can go to those other things. So cosec, so 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 something that I would like to talk about here again, it's about the more you practice, the more you know how to go about these things. So now you will realize that this particular question, it would be way easier for me to actually start from the left. Oh, sorry, to start from the right. I could start from the left, but when you look at what you're having on the left, you're having uh, cosec theta plus cot, that's cot theta. So what you do in that particular context, you want to use the concept of what? Multiplying by the conjugate. And so, in which cases can you use the multiplying by conjugate? It's when you've got a situation where the base is like this. Then you can use the what? You can use multiplying by conjugate. So how you're going to do this? So remember, with proving identities, you can start from either side, isn't it? Just trying to prove. It's not like they're telling you that start from this side, start from this side. So that's really where the thing really is. So that's where really the thing really is. So anyway, so let's start. So you do the multiplying by what? Multiplying by the conjugate. So conjugate, you just change the sign there. So uh what are you going to have now? So you're multiplying through, right? Okay, since multiplying through may seem like a big issue, so we are just going to leave the sign outside. Now, you will remember from the time when we were looking at complex numbers, we talked about a concept called difference of two squares, right? You see that this is the same. That's difference of two squares. And whenever you have got difference of two squares, we know that our answer has to be like that. Maybe just for the sake to help someone. So, how you do it is you come and multiply. So 1 times 1, 1. 1 times cos, there it's going to be cos theta. Then negative cos theta times 1, negative cos theta. Negative cos theta times cos theta, you see it's negative cos theta squared. So you see that the middle terms cancel out, right? So that's the difference of two squares. Huh? Okay, so that's about it. So once you've reached this particular point, then you are almost done, right? Then what you then do is you say, what identity can I use to replace what's on the base? Okay, what can I do to replace what's at the base? You know this identity, we've talked about it a lot, but let me just write for the sake of revising. So yeah, so you see that this is that. Okay, so meaning here we write, so we've substituted that. Okay, now one thing that you want to remember is that this is the same as what? It's the same as that. So meaning you can actually cancel out that sign and you're going to remain with this. Okay, so you're going to remain with that and that. Now you may remember from fractions to say the denominator actually works for both. Okay, and when I say for both, it simply means when this denominator is down, it means that it's both for this part and it's also for this part. Okay, so how I'm going to show this, uh I'm going to rewrite it so that we can see it properly. So you say this is the same as sine, then this is cos theta, then that's sine theta, right? So once you've done that, you may see that what you are having then here is what is cosec theta, and here it's what is cot theta. So remind me, I'll be able to upload a a link on Google Drive for the what's this for a video that I think would be helpful just to help you practice more on these. Yeah, but having done that, I would then like us to talk about what we call the double angle identities. But before we can look at the double angle identities, let's look at what we call the sum and difference formulae. Okay, so there are going to be certain times where you have to calculate, hello. Okay, yeah, so there are going to be times where you have to calculate, let's say, sine 15. Now you know that from all your calculations that you do, you usually work with sine 30. So then how do you calculate sine 15 and how do you go about those things? So again, those are things that we are going to look at. Okay, so the important principles that we are going to use are what we call the sum and difference what are identities. So I'm going to write them so that we can, and then we're just going to utilize a few. So in case you've got somewhere where you've written those what do you call them? Sine 30 is equals to square root of what? In case you've written them somewhere, please kindly just put them nearby so that you can be able to assist me with those values. So just remind me to share you with you the link for different what's this identity proving, so that at least you can be helped. So what we'll look at is this. So there is, for instance, you're asked to say find sine 15 degrees, and you know that for you people don't use calculators. So how are you going to go about a question like this? So that's where this sum and difference identities come in. So how you do this is you are going to say for sine. So there are quite a number of things that you have to know on this topic though. So what you're going to do is you can either say, let's see, I'm going to say, okay, let's first write the equations. So you have to know these identities. Sorry, should be sine A cos B plus cos A sine B. So you see, it's just like they are just swapping them, right? Sine A cos B cos A sine B, right? So that's about it. Then there's also this one where sine A minus B, we are going to have sine A cos A, oh sorry, cos sine A cos B, then minus. So you see that the only thing that has changed there is what? Is the sign, right? Because of the sign that changed in the brackets. Okay, so then how then can you use these particular things? So if let's say you want to solve we'll get to sine 15, but let's first, maybe you want to solve, maybe let's say sine 75, right? Okay, 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 what's this? Yeah, so sine 75 degrees. How do you answer it? So you see that what two common angles can you use for you to find sine 75? You say, oh, okay, I'll say sine 30 plus 45 degrees. Okay, so yeah, that's the same thing, right? So then you can now designate, maybe you say your 30 will be your A, your 45 will be your B. Okay, so with this, you just have to again know the formula. So A is 30 degrees, then cos B is 45, then plus cos A, then sine B, which is what? 45. So again, that's where those special things that we discussed when we just started the topic, where you have to know sine 30 on your fingertips. Yeah. And I promise to send you a link for a video to help you remember those. Yeah, so I will send you those videos. I'll upload them on Google Classroom today. So then here just begin to factor in the values. Okay, so then you are going to have um, so common denominator. So that's how you can make use of it. So in the interest of time, I'll just show how you could calculate sine 15, and you can try it and then counter check your answer with a calculator. So how do you find this? You say 45 minus 30. So meaning that 45 is your A and 45 and 30 is your B. Then you just use this second formula that I gave us. Then you can find it, right? So that's how you make use of these particular uh, equations. So I don't know if there are any questions before we can look at the other questions. Okay, so there are no questions. Hello, are there any questions? Hello? Yes, you're saying you've got a question, you can ask. Yes, you can ask. Okay. Were you there the time when we were discussing SADs? Hello? Okay, so how SADs are is this. When you've got you get so if the things which are in the square root are the same, that's when it's the same as what? It's the same as doing this. Then it's this square now. This square that cancels the square root, and then you are going to have what? You are going to have a. So for instance, if we had square root of 2 times square root of 2, the answer would have been 2, because it's basically the same as saying square root of 2 raised to power 2, which gives us what? Which gives us 2. But then the principles of SADs tell us that if we've got that and we've got that, the square roots are not removed. Rather, you just multiply like that. You get it, right? Okay, sure. Yeah, so that's yeah, but that's a very very good question. That's a very very good question, I must say. That's a very good question. So yeah, so having done that, let's now go to the sum, sum and difference formula for the course. For course, so course, so for course is relatively easy to remember because you just start with course, then you go with the sign. Oh, sorry, I forgot something. Here it has to be. So the only tricky part for this one is, unlike the sign where when it's positive in the bracket, it's also positive. Oh, sorry, pardon me. It's fine. So yeah, so you have that. Then you're going to have So we are going to have sine. Yes. Hello. Oh yeah, 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 yeah. Sorry, sorry, sorry. Yeah. Here it's supposed to be negative. Yeah, it's supposed to be negative, right? Okay, great. Yeah, thank you very much for that. So they are negative, so meaning that here it's going to be the what? It's going to be the opposite, right? Okay, so meaning that there it's going to be the opposite. So being the opposite in terms of the sign, so here it's going to be positive. So the reason why these are important is because they are the ones that we are going to use when finding the double angle formula and also the half angle formula. They are derived from these same concepts. So that's why I actually decided to start with these, because once we understand these and we do the double angle formula, it's easy to understand the double angle formula. So let's look at an example. Since the one that we looked at earlier on was for positive, let's look at one for negative. Huh? So let's find cos. What angle will be interesting? Let's find cos 15. So how can we find cos 15? We say 45, uh, 45 minus 30. So please, just someone to be able to be looking at their what sine 45 is, what sine what is, so that we can go through this quick. So we know that what we're having there is what is subtraction. So here we've got our a, here we've got our b. So what we're going to have, we are going to have cos. Okay, so we are going to have cos a, cos. Okay, pardon me. So you're going to have cos A, cos B, then plus sine A and sine B. Okay, so let's now start putting in the values. Okay, let's just write them first so that we don't make mistakes. So that's that. Okay, so here I'm just going to ask for someone just to kindly help me to tell me the what's this, to tell me the values of this. So what's cos 45? Okay, but I thought I had asked that someone to be looking at them. It's one? Okay, so remember, if something is one, hello, what I, yeah? You are saying it's what? Okay, so whenever something is 1 over square root of 2, remember you don't write it like this. Remember we talked about rationalization. Huh? So you want to rationalize this so that what you're going to write is square root of 2 over 2, okay? Yeah, so what we are going to write is square root of 2 over 2. Okay, so square root of 2 over 2. Then what's cos 30? Square root of, Okay, thank you. Then sine 45, root of 2. So it means sine 45 and cos 45, they are the same? Oh, okay. Then sine 30, 1 over 2. Okay, great. So what we do here is, uh, so we say like what we did there. So it's going to be 6 over 4, square root 6 over 4. Then here it's going to be 2 over 4. So it's going to remain. So here you just put the common denominator of 4. So it's going to be 6 and that. Yeah, I think that should do it, right? Yeah. Wait, so does it mean that cos 15 is the same as sine 75? Okay, let's just check this because I've just realized that it's the same as what we found earlier on. Sine 75 sine 75 is giving 0.96. Then cos 15 cos 15 is giving, oh yeah, they're the same. Okay, that's interesting. Yeah, because I got quite concerned when I saw that both answers were the same, but we are actually on the right track. So really, so that's really about it. So let's just look at tan uh, for these, and then we can start looking at the double angle formulae and how to derive them. So basically, this is about, so it's just about really knowing the formula for these things. It's just about knowing the formula for these things. Yeah, and I think maybe in the interest of time, I can just give the formula for tan since the concepts are the same, so at least we can go to the double angle formula. So I'll just give the formula, but you can always try out a number of questions on your own. Uh, that would be helpful. So please, in case you note a mistake in what I'm writing, please tell me. So that's what you are going to have there. So we see that that's if we are adding two things in the bracket, and if we are subtracting, the signs are just basically going to change, isn't it? The signs are going to change. So you're going to see that there it's going to become, then tan A and tan B. So just like we did for the other questions, you just plug in those particular values depending on what you are trying to find, and you find your answers like that. So really, the key thing is practicing, because the more you practice, first of all, the quicker you are going to get. So that's my encouragement for this topic of trigonometry. Ensure that at least you can even write these things somewhere. You're always looking at them. That's going to be helpful. And you see how these particular equations are helpful in the double angle formulae, or you can call them double angle identities. I know that trigonometry is a very long topic, but I just don't want us to rush through. So now let's derive these, because I feel when we derive them, it's easier. So what double angles are basically, it's where you see that x there. It could be x, it could be sine 2, but you see that it's double, right? It's double angle. Okay, so that's something important to take note of. So how we do this is we are going to look at this is the same as, and you want to remember what we've discussed so far, to say it's going to be sine x cos x plus cos x sine x. So now you know that addition is what you call it commutative, right? So meaning whether it's sine x cos x or cos x sine x, it's still one and the same thing. So you just combine them and say 2 sine x cos x. So that's the double angle identity. Very important things. You see how important they are in a short while. Then for cos 2, it's the same as cos x plus x. So again here, if you know what the sum and difference formulae are, deriving these things really becomes like revision of those things. So that's why even in my approach, I'm trying to build on those things so that you have got less things that you have to memorize, because when you can derive things, it's easier. And when the more you practice, okay, so this is, yeah, the more you practice, the more these things really stick to mind. Okay, so that's that, right? Then for tangent, so this is the same as, so you see there it's addition. So even on top it's going to be addition. Then down the sign is going to be opposite to that one which is on top, right? So that's how you can remember these things. So since the two things on top are the same, you can say you add them, then there. Okay. So these are the ones. Now there is something that's interesting about the cosine, because the cosine double angle has got other forms, and these forms are very very important when it comes to solving equations, because you find that you're going to find certain equations where you have to solve a question and it's cos 2x plus 2 sine x plus 4 is equals to 0. How do you go about that? So you see, you can make a quadratic equation from the understanding that you can make a what? You can actually figure out how to bring a squared angle in that, right? So what you do for the cos double angle, it's very interesting because it's going to have several forms, and these forms are very important. So we know from this identity. So what you do is, let's say cos x sin x the subject of the formula. Then let's make cos x squared the subject of the formula. Okay, so having done that, then we can now want to substitute into this equation on our left. So let me use a different color so that we can appreciate it. So we are going to have, so here when I say okay, let me substitute for cos. So I'm going to substitute for cos, then I'm going to have, where there was cos squared, I put 1 minus that. Okay, then so these are going to be very important when we start solving uh trigonometric functions. Okay, that's why I didn't want us to rush to trigonometric functions without understanding these things. Okay, then so that's one form of that. Then we can also have where we substitute the sign, so meaning we leave the cos squared, then we substitute the sign, so we are going to say that. Okay, then we now distribute the negative. Okay, so we are distributing the negative, then it's going to be 2 cos that minus that. So again, so if this means that if you've got a if you've got a trigonometric function which you've been told to solve, and maybe it's been written something like cos 2 sin x plus 4 is equals to 0. It simply means you can solve this as a quadratic equation by simply replacing this by that, and you solve. So you see, that's why I didn't want us to rush into going into the equations, because if I wrote this, maybe perhaps not everyone would appreciate it, right? So you see, I hope you are seeing how these things are very, very important when it comes to solving of trigonometric equations. Okay, great. Let's now look at equations which we call the power reducing identities. So there are going to be certain times where rather than uh, rather than increase the power, because those we've seen how you can change that double angle, and you are simply increasing the power, right? But then there is a way in which you can actually reduce the power, and so that's what we are going to do. So here we are trying to reduce these are power reducing identities, maybe from sine squared to cos 2x or to sin x. Okay, there may be certain times where you may want to do that, more so when you want to solve a trigonometric equation. Okay, so let's dive into this. So we call this the power reducing identities. So lovely. So power reducing identities. So these are gotten from the double angle. So the double angle identities are very important, because when we look at the half angle formula, again we use these same ones. Yeah, pretty much we use them to some degree. So We write this as, okay. Then what you're going to say is, uh, let's move the 1 to the other side. Or if you don't want to struggle with the negatives, here is what you can do. Because sometimes dealing with negatives can be tricky, so you can just move this here and move this there. So at what you are concentrated on, because sometimes these two negative signs, they can cause confusion and mistakes. Okay, so you see, I think that's easier and you avoid mistakes like that. So that's the sign. So I'm sure you've seen that in everything that I'm doing, we are not memorizing, okay? We are simply building these things. And the beauty when you build them is that they don't get to confuse you. And neither do they make you anxious when you see a question. So you see, I started with, so you see now, this was raised to power 2, but now I have something in terms of what? I've got something in terms of power what? In terms of not raised to any power. So that's why we call it power reducing. Okay? So now let's do for the course now. So for the course, you do this. So what you're trying to do, since you're trying to solve for the cos, right? So you're going to use the one which has got the cos having a what? Having a square. Okay? So that's why we are going to use this. So since here there is no negative, so we can just go direct. Okay. So maybe perhaps you may be wondering why I didn't just drop these equations to you and then we start solving. Well, when I just drop them to you, they tend to be a little bit more confusing than when we go through them together. So those are your power reducing identities. So now let's now go to the half angle identities. Then we can now begin to do questions. Okay? Then we can begin to look at questions. Because once we've done this, I think then we can answer a range of questions. Because I'm sure if even you just looking at what we've derived so far, you can see just how many questions you can answer in your tutorial sheet. Okay. So what you are looking at here, it's half angle identities. What you are trying to do is you are trying to find, let's say, um, you know what sine 30 is, right? You can find it. But then, yes, we can, yeah, but then, what if you want to find sine 15? I know that we can use the sum and yeah, we can use that difference formula, but then we can also use the half angle identity. So that's where these ones come in handy. And what we do here is that we use the formula for the power reducing identities to be able to derive these ones. So Let's start with the one for the sine. So for the sine, the power reducing identity for the sine was this. It was this, right? So if you want to, so how you're going to find your half angle is you introduce the square root and the square root. So then you're going to say sine x because of the square root, so you've gotten rid of one other thing. Then it's going to be plus or minus because there is a square root, and more so, you know that depending on which quadrant your angle is in, okay, depending on which quadrant your angle is in, this can either be or rather have a positive or a negative sign. Don't worry, we'll look at the examples, but that's what that plus or minus sign is there for. Now remember that our focus is to what? Is to establish a half angle identity. So what you then do is where you have that x there or that angle there, you just simply make it what? Half. So you've done half, then here plus minus. Now here you had 2x, right? So if you have 2x, then you now have then you're now having the half, huh? The half in there. What are you going to have? We're just going to have what? X, isn't it? So that's why that cos 2x that was there, because it's now a half angle. You see, you've multiplied that and you're only remaining with what? With an x. So it's cos x over what? Over 2. So this is the sine half angle identity. So because of time, we'll proceed tomorrow with the cos half angle identity. And once we've done that, then we'll just look at examples. Then now we can do equations, because I think having done that, then we are set to go to be able to answer those other questions. And the beauty with the half angle identity is that you are able to solve things such as sine 22.5, because this is just the half angle of what? Of 45 degrees, isn't it? So you see, so the half angle formulas are very, very important, and I'm sure you've seen questions in your tutorial sheets. So that's something that we'll definitely be looking at tomorrow. So, are there any questions, any concerns?